All right, so strings can do things on themselves, as we know, because strings are just objects, and objects have these things that we introduced this term last time called methods. These are special functions that are associated with those objects. So if I have a string which is funky with a capital KY and then a capital O in town, and I do dot capitalize, what does it do? It assumes that this is a sentence, and it'll wind up taking the first letter, and if it is not capital, it'll make it capital, and then it will wind up making everything else not capital. Now, is this changing the string funky town, or is it returning a new string? It's returning a new string. Remember from last time we talked about strings. Strings are immutable. So if you're going to do anything to them, you basically have to operate on the strings and return another string. Same thing with lower. So it just takes everything and just makes it all lowercase. See if that works if I do that. Okay. I can swap the case. So if it's uppercase, switch it. If it's lowercase, switch it. Now we can also split up strings, as you can imagine. So here's our funky town again. We're going to split that up. And what does it do? It returns a list back to us, a list of strings. As you know, we can do a bunch of things where we can capitalize something, which would effectively return a string. And then we can do something to that string. And then we can do something to that. And then we can do something to that. Oftentimes, although this can get ugly if you're just adding a whole bunch of these dot methods, this is a nice sort of succinct way of operating on a string where you don't have to do this in multiple lines, and you don't have to create new variables each of those lines. What's happening here, we're going to capitalize funky town, and it's going to wind up returning a string. That string will be held in memory somewhere, and then we're going to split that up. So we get back a two-element list. By the way, as you can guess, split is splitting on the white space. You can ask split to split on other things, as we'll see in just a minute. We can also use list comprehension to do the same thing we had before, where we can, instead of, let's take a look at what we're doing here. Instead of capitalizing the string first and then splitting up the resulting string, instead what we can do is split the string. And we're then going to assign temporarily the variable x to what's in each of the elements of this list that gets returned. And then we're going to capitalize x, and then we're going to make a list out of the result. So this is probably the result you wanted if you were saying, hey, capitalize this and then split it. But you notice you got a slightly different result because the letter T here is capitalized and it's not here, or the other way. Any questions on what I just did? List comprehensions, once you kind of get your mind into it, winds up becoming very useful. OK, so I want to take you to funky town, and I want to split that now not on the empty space. I want to split it on the letter U. This is going to split it every single time it sees the letter U, and it's going to remove the U's. I want to take yo, and then space 2, comma F, unky town, or unky town. I can split on not just one letter or one character. I can split on entire strings of, or sequences of characters. And here I'm just going to split on U. Any questions? What do you think happens if I split on a letter that isn't there? It will return the string itself, but in a list. So it's going to be a list of 1, right? So here we split on the letter X that wasn't in there, so we just got the whole string back. All right, so let's actually do some work with that. We're going to look at this thing called strip, join, and replace. So CSV underscore string will be a new string that I'll create. And I'm going to start off with a fairly ugly looking comma separated file, at least one line of that. Dog, comma cat, comma spam, comma defenestrate, a comma 1, comma space, and then a number, and then a bunch of other stuff after that. So if I click this to strip, what do we think strip does? Removes the white spaces from the beginning and the end. Let's see if it's true that it's the beginning and the end. So let me add some white spaces there. Yep. Obviously well, not obviously, but hopefully if we did this, we'll learn a little bit about what strip actually does. Returns a copy of the string S with the leading and trailing white spaces removed. If characters is given and is not none, remove those characters instead. All right, so let's try doing that. So let's try to strip out the \t. Okay? All right, so now we've got a new string we'll call A and spam \n. Remember, n is the special character for the new line. If I do strip on S, I get Pam, right? Because I actually removed the letter S and not the \n. All right, so let's do list comprehensions again. And instead of just printing out the results of the list, let's actually store the results of the list. We're going to call it clean list. And here's what we're going to wind up doing. We're going to split that string that you see up here with a comma. So each one of these things will be its own sort of element in the list. And then we're going to wind up stripping out the white spaces at the beginning and the end. And we get something which probably is close to what you'd want if you're going to be processing this data. Obviously, we need to handle the fact that perhaps we wanted to consider this an int and we wanted to consider this a float, but we'll deal with that later. Yep. This is the way to do it within Python. So really the only effect it would have is how it actually gets visually displayed. It's still handled across all platforms identically. It's still considered one character, even though you had to do 2 keystrokes to do it. If you did the split on it, it would still, across Windows, it would still wind up splitting. Someone can verify that, but it should behave the same across. It may get printed out on the screen differently. All right, so as you can imagine, there's the opposite of the splits. There's also the joins. You'll find yourself using this a lot. And the way to do that is to say, join is basically a method on a string. And what you're saying is, given a string, let's say comma, I want to join those, everything in this list together with that. And join knows that you probably didn't mean to add a little comma at the very end as well. So you notice that it put commas in between, and I can put anything I want here, right? But it didn't put a comma at the end. And instead of commas, maybe I want to make a tab-separated line, so I can put a \t, and you notice I got this out. If you want to actually see the t, instead of actually printing it out, we can see that. Any questions on that? Okay, so we can also replace white spaces if we'd like with nothing. This is kind of a nice way to take all the white spaces that are in between these elements. So we should probably zoink out this right here and this right here. You can use a dot replace. So here we're saying every time you see a white space character, replace it with nothing. And this is probably the thing you'd want to do if you're pre-processing a CSV file, just to sort of clean it up before you actually put it into something like a CSV to rec. Yes?
It seems like the previous syntax would lead you to think it would be something like clean _list dot join with the t in there, as opposed to like the method is on the string you're at.
Yeah, it's... Only because it's sort of the inverse of the split. The question is, why are we doing the logic where it's a method on a string and not a method on the list? Only because it's the direct inverse of doing a split, where you actually give it the character letter. So now you could actually show that, for all x, if you do x dot split on whatever character y, and then you do dot join on that with y, you wind up getting the same thing back. I think that's the way to think about it. There's probably lots of emails about that, from 1994 where people were trying to figure out the right way to do it. All right, so any questions about the strip, replace, join? You'll find those to be very, very powerful, I think. Okay, let's go to look at find, where we can actually find things inside of strings. So we're going to find the letter Y. We get the number 1. Why do you think that is? It's zero-based index, and we didn't get all the letter Y's, we just got the first one. So when you do a find, you wind up getting just the first occurrence of that. Let's see what it says. So I tell it where to, I tell it the string, I tell it where I want it to start in the index and where I want it to end. That's optional. And then it will wind up returning -1 when it fails. That is when it can't find the string. So s.findFunny is 3 because 0, 1, 2, 3, that's the beginning of where funny starts. Now I can say, give me everything of string s indexed by wherever I find funny, and then keep on going after that. So what did this do? This basically resolved to the number 3. And then we saw last time when we did the slicing operators on strings that if you do 3:, you get everything from the third element onwards. Okay, let's find z -1. We didn't find it. So oftentimes what you'll wind up seeing when people are working with strings is that if you're looking for some occurrence of a string in something you've just been given that you don't know what's in it, you might say, look for the letter x in that string. If it's not there, if equals -1, that means it's not there, do something. If you go into the else part of that if loop, then you wind up actually assuming that it's there. So we can loop over lists. So we'll create a new list called SS, and then for the string in SS, if the string find not equals to -1, that is, it's there in the string somewhere, print stuff contains the substring tine. My funny Valentine contains tine, Argentine contains tine, quarantine contains tine. Manafort does not contain that. All right, so any questions about that? Yes? Yeah, so you can, the question is, can you concatenate a bunch of methods on that string? When you concatenate, like we had up here, what you're actually doing, even though it looks like you're concatenating it on and doing a whole bunch of methods on this string, actually what's happening is you're doing the first method that's closest to the string first, it's returning a string, then you're doing the next method, it's returning something. In this case, it's returning a split, so this, lower should fail because lower doesn't know what to do on a list here. Makes sense? So if you wanted to, you just got to make sure that the last time that you do this, this should work, right? Because I'm capitalizing it, then I'm taking it all uncapitalized, then I'm splitting it. Okay. Now, there's more than just the built-in capabilities within Python. There's also, for string manipulation, there's also a module called string, and that has some very useful variables associated with it. So string.ASCII letters gives me all the ASCII letters. So for instance, if you wanted to say, T in that's true, question mark in that is false, right? So if you're looking for things that are in your input and you want to basically see whether they're ASCII letters, you want to see whether they're digits or they belong to the uppercase ASCIIs, then you get access to that without having to type that out. So those are just sort of convenience variables that are for you. Yeah? Say that again? Which previous example?
This one.
Yep.
Writing code and you're typecasting the string as string. Why do you have to do that?
That's a good question. It could be that I have the number 1 here, and this is just to save it, although because we're doing a find, there's an assumption that all these in here are strings. So I think you're probably right in pointing out that we don't need that. Yeah, thanks. Doesn't hurt. So there's a whole bunch of interesting things that you can get out of this. Is it printable? What are the hex digits, et cetera, et cetera. So just take a look at it. Yep. Is period a digit? It's not considered a digit. Let's see what other things we have here. Uppercase, lowercase, cap words, formatter, hex digits, printable, punctuate. I bet it's part of the punctuation. Oops. It would say not all digits, but if you wanted to see whether a string was convertible to something without having to raise an exception, I think what you could say is 1.23. Let's say a equals 1.23, and then I think there's an a is decimal or is numeric. False. No, but this is a method on a string. There is a way to figure that out. Let's just see what isDecimal does. Returns true if there are only decimal characters in S. I don't know why the isNumeric is not working on that. Turns true only if there are numeric characters in S. There must be another one that I'm missing. Is maybe, what's that? Is alnum? Let's see what alnum is. Alnum. Or alphanumeric. Let's try that one. I don't know if that's exactly what we want. Somebody will figure this out for me. I thought there is a way to do that on strings. The other way to do it is to say, float A, and that'll wind up working. But if A is that, you wind up getting an error. What we'll see a little bit later on is you can wrap that in a try except statement. So that is one way to do it. I thought there is a method on string. I'm just forgetting what it is that allows you to do that without having to throw an error. Okay, any other questions? Maybe somebody can figure that out.
It's just an isFloat method. It's not a method on the string. It's just a function.
Oh, okay, let's try that. So is float. It's probably something else you pulled in your namespace. Yeah. All right. Well, extra credit for whoever figures it out. All right. So let's just now go into string formatting. We showed you there are a bunch of different ways to do formatting. What I'm going to show you here is sort of the old school way of doing it that you'll often run into if you're looking at people's code, especially if they've been using Python 2 for a while. We're just going to import the math module. And you'll notice here I've got a %i, %f, %.3f, and then %e. And I'm basically going to say the number 3, math pi. So my favorite integer is 3, and my favorite float is this. And Python decides when you're just saying arbitrarily do a %f, how many decimal places to show you. But you can say, no, I really only want to see this to 3 decimal places. And then in exponential form, you can have it print out that way as well. Okay, so Percent sign I is for integers, percent sign F is for generic floats, percent sign F, but with some stuff in front of it, is also for floats, and then E is for exponential. There's a whole bunch of information. Here I've linked to the 2.7.2, but there's an equivalent in 3.5.2 of the different ways of getting these different formats. If you really wanted to get a percent sign, you'd have to use an escape character for essentially the variable substitution, which is a percent sign. Although, wait, that didn't work. There we go. That works that way because I didn't wind up having some sort of substitution here. So here it tried to actually do the substitution, and it realized that there was some formatting, and it tried to put it in. But it looks like we can actually get it this way. Oops. Here is a whole bunch of other ways to do zero padding and things like that. Let me just print it out, and then we can see what it's doing. Percent sign F, that's just printed out. Percent sign F, but with a plus in front of it, forces it to have a plus sign, even if it's already positive. If you just have percent sign F and it's a negative number, it will show the negative number, of course. And then 10F means use 10 spaces. And I believe the default is to write justify, so it uses all the spaces on the left that it can. And then percent sign S here, 10S, means actually spell out the word because I'm assuming that that's a string. Okay? There's lots and lots of formatting tricks and things like that. As you probably can guess that once you know how to do this, the breakout session from, I think, the first lecture yesterday would have been a lot easier, rather than you have to do the math of how many characters does this destination take up and then add in a couple extra white spaces by hand. Now you'd be able to use these formatting strings to get the answer. The kind of newer, somewhat more preferred way of doing this is instead of doing the string and then percent sign and then all the things that you're going to substitute in, to use this dot format method where you have a series of arguments to that format, and you have essentially placeholders. Now instead of the percent sign, you're going to wind up doing curly brackets inside. On curly bracket 0, I feel curly bracket 0. On Saturday, I feel Saturday. That doesn't make any sense. So what it's doing is it's referencing the first argument twice, which is kind of nice because you remember the old way to do it would be if I want to use this variable pi over and over again, I actually have to explicitly write that out. What's nice about this now is that you can just say, no, if I want to keep on reusing one of the arguments here, I don't have to keep writing that out. I just know that I'm going to wind up referencing that. So on Saturday, I feel groovy. That makes more sense. On no number inside of those brackets, on Saturday I feel groovy, what's happening is that as the string is printing out, there's an internal counter which is saying, which argument do I use now? Okay, I'm on the 0th argument, I'll take Saturday. Oh, I hit another one of those things, I'll take the next argument. What do you think happens here? It runs out because it says, ooh, I need to do another string. I need to grab that from somewhere, and you didn't give that to me. But if I said that, do you think that would work? Can't switch from automatic field numbering to manual field specification. That's pretty specific. So if we wanted to do 0, 1, 0, that should work. Okay? How do you think this is what's going to happen here? Why? It's a list, and so what I've given it is an argument of unit of length 1, which itself is a list of length 2, that indeed does wind up giving us an error. So if I wind up doing just this first one, so I just wind up referencing this list, that actually works. That's probably not what we wanted, but you see that Python said, well, you probably, I'll just represent this list as best as I can and print that out for you. Everyone see how we did that? Obviously, the ordering at which you show and pull the numbers doesn't have to be sequential in your string, so you can pull the second one first and then the first one second. That's kind of nice, but I think even nicer is now the ability to actually name the variables that you want, which is pretty cool because oftentimes when you're building up large code bases, you're printing out these strings and then you realize, actually, I want to print something else out. And then if you're doing that, you have to worry about the ordering at which you wind up giving it as arguments to this thing format. Instead, you can say desire to place, and then you can actually now not create arguments, but keywords, desire equals fly me and place to the moon. Desire to place, or else I won't visit place. So this allows me to pull place twice, which is kind of nice. Fly me to the moon, or else I won't visit the moon. F equals desire, so this is a dictionary. And here's the keyword value, and now I can just unpack that dictionary, and that double star should be familiar to you from when we were doing modules and functions yesterday. Oops, I didn't execute that. I want to take you to Funkytown. Any questions about that? Yep.
So can you mix the percent style formatting with this positional style formatting? So can you say like desire 20s or something like that?
No, I don't believe you can. We can try it. I never have tried it myself, but we can try. I guess we'd want to do a dictionary here, right? Doesn't know how to do that. Yep.
So then can you use single star variable name with a list then?
Can you single star variable with a list? Let's give that a try. Yeah, let's try my list here, and I'll say Happy Berkeley, and then we'll just do this. I think that should work. Now, if we said desire, it doesn't know what desire is because now it's looking for a dictionary. It turns out you can have more complex things here, so you could actually have individual elements here which then get referenced inside of here, so you could actually get access to a key of a value of a dictionary if you really wanted to. That, I think, gets kind of complicated. Formatting will come after colon here. This is what we saw before, formatting from the old world way of doing that. But in the new world way with these curly brackets, here we're basically saying choose the 0th element, and then colon, here's how I want you to format that for me. And if I want to take the first element, I can do that. Okay? I won't be able to go into all the details of all the formatting. I just wanted you to see an example of that. We can establish what we want the formatting to be kind of ahead of time, and then you can use this if you'd like, but again, the proper way to do it is to use this format. Improper format specifier, what?
Does that percent sign have a name?
Does it have a name? Oh, sorry, here, I'm doing something different. I don't remember what this is called. I call it the old school way of doing printing. Here, so what am I doing here? I'm actually creating a format on the fly using a variable. So if I didn't know this variable ahead of time, so here I'm going to wind up saying $i. I'm going to stick it into this string formatting. I'm going to print the string formatting, and then I'm going to use that format on new strings. And here you wind up seeing I left justified 10 characters. Everyone see what I did there? It's kind of interesting, right? Because that means you can dynamically decide what the formatting is going to wind up being. That is at runtime. You can do it with integers. So again, it's using some of the old school ways of showing integers and hex, octals, binary representations, etc. What is the last what? The less is just saying right justify. Oh, sorry, left justify, and I think if we do this, it right justifies it. And then there's center. There's a whole bunch of things you can do. All right, any questions on strings before we move on? All right, so now we're going to do some file I/O. On the homework, you were actually reading in files without kind of knowing it. You were actually using CSV to rec, which was opening up a file somewhere on disk and then doing something and then closing that file. We're going to do that explicitly now. Yeah.
One more question on strings.
Yeah.
Is there any regular expression capability in Python or active expression?
Yeah, exactly. So good. So regular expressions are sort of a more expressive, much more powerful, and actually much quicker way of doing searches and replacements in strings for those that use it. You can import the re module, which comes with Python, and you wind up doing a find all, for instance, which allows you to do regex expressions as you'd expect. There's a bunch of other regex modules that are out there that are third party that are considered better than the one that comes with Python. But this is going to get you 95% of the way there for most of the things you'd want to use regex expressions for. And when we see with pandas, you can actually use regular expressions to operate on columns, and when you read in data, you can actually specify regular expressions. It's kind of powerful. Okay, so open and close, as you imagine, are methods that we'd want to use for file I/O. So let's create a file on disk, call it mydata.dat. This is my 0th file I/O, zing, that's what it's going to say. And now what we're going to do is open up that file in read mode. We're going to print the type of that thing that got returned, and then we're just going to close it down. So when we open it up, we got an _.io.text wrapper IO, or text IO wrapper. So that's just a type of file string. That's stream. That's how Python winds up considering open files. These are file handles. There's the read mode, write mode, read plus update, read this as a binary, read this as a text file. Lots of different ways to open up files depending upon your use case. Let's open up a file for writing rather than having to use the IPython stuff to do that. Let's write, this is my first file IO, and then let's print it out. So remember what this # does within Python. That just says go to the shell and print out and do whatever I say here. So cat is a Unix command. Okay. Now let's open up a file. Let's write it again. Let's do, instead of doing a write on that file, let's do a write lines. And write lines winds up expecting not a string like write, but instead a list of strings, or actually you could do any iterable should work. So I believe a tuple of strings would work as well. So we're going to say A equals and then something that looks like a list. And we'll show what that looks like. And you wind up noticing that it didn't add a line break there. So maybe I want to add a line break explicitly. And likewise, just like there is the opposite of split and join, there is the opposite of read and read lines. By the way, is it clear what the distinction is between write and write lines? What's very nice about write lines is that let's say you're doing something in a very large for loop and you're operating on a bunch of data. The nominal thing you'd want to do is say, well, each time I'm done at the very bottom of the for loop, let me just write the next result into my file, my log file, let's say. The problem with that is it means throughout your entire for loop, you're going to wind up keeping your file open, which is OK, but it's somewhat more volatile, like if your program crashes or something like that. You won't know where you left off. Oftentimes what you'll do is you'll create an array at the beginning of your for loop or at the top of your for loop that says, here's my empty array. You'll fill up your then now not empty array with basically strings that you're going to wind up writing out. And after your for loop finishes, you open up a file, write all the lines that are in that array, and then close the file. It's stylistic how you're going to wind up doing it. And obviously, if you have really long-running for loops, you might actually want to be opening up a file, writing something, then closing the file, and then continuing on the for loop, so you really don't lose your place. But it's kind of weird to have a file open while you're not actually doing anything with that file. So that's how I think of the difference between write and write lines. OK, so read and read lines. So I'm going to open the data for reading. data equals f.readlines. I'm going to print the data. There we go. We got it back. Type of data is a list. So I get back a list when I do a read lines. And what it winds up doing is it winds up splitting it for me across lines. Okay, so now we're going to create a new little program here called Tabify My CSV. So we're going to take as an input a CSV file, and we're going to rip out all the commas, and then we're going to wind up putting in tabs instead, okay? And we're going to make sure that if there are commas in comment lines, we're going to ignore those as well. So we're not going to remove all commas. We're only going to remove the ones that are part of the data. So let's take a look at what that is. So we're going to import the OS module, because OS gives us the ability to look at file paths and test whether a file is a directory, whether it's executable, and all that good stuff. Create a function that you saw last time. And remember, the function has a variable number of arguments and a variable number of keywords. The arguments are required, the keywords are not, and you will wind up giving a default for what those keywords would be if you don't wind up giving it. The input is a file name. The output creates a file called outName. This is a pretty terrible doc string. What are we going to do here? We're going to create a tab separated version of a file which was CSV. Okay, better doc strings. If not OS path exists in file name, so that means if it's not there, don't do anything. Just return back. F is the in file name, and we're going to open it in read-only mode. O is the output name, and that's going to be write mode. Inlines is going to be all the files that all the lines I want to read in that file, which is basically everything in the file. And then we're going to close it. Outlines is this empty list. And then we're going to loop over the lines. And what are we going to do in each one of those lines? If ignore comments, which was a Boolean, is true, and the first character there is in the comments, so all of these would potentially be comment characters, just take the line that I had. Otherwise, replace every time you see a comma with a \t and append that to my outlines list. And then at the very end, use write lines, because I now basically have a whole list of strings, and close it. Any questions about what this is meant to do and why we made some of the decisions we did? Yeah?
What if the comment occurs after code?
We're not going to replace code. This is explicitly going to be a CSV file. And by convention, one of the assumptions is, which again, if we had better doc strings, we'd say, is that the comment string has to be the first character of that line. So typically what you'll see is, hashtag, and you'll see a whole bunch of stuff about the provenance of that data, and then you'll see the first header line, and then you'll see all the data under that. That's what a typical CSV should look like. Can anyone guess why this might break a CSV file? And when I make a tab file? Yeah.
You might have strings in there that have the main comments in them that are quoted.
It may have what?
You may have strings that contain comments that are quoted.
Correct, exactly. So if you had a perfectly valid CSV file and one of the columns was, sentence, that was the name of the column, and then that value on line 4 was, quote, here's my dog, comma, mom, period. That means that I don't consider that a comment line. I would wind up considering that column as part of a valid data line. I would replace the comma there with a \tab. So if you were doing this for real, you would really want to actually look at the character level, count the number of quotes, make sure there are no commas inside of quotes that are part of a valid data line. So this gets ugly pretty quickly, you can imagine, but at least we now know that we've got some limitations. Okay, so I wrote that file, and I can now take a look at the CSV file that I have here, which is just Google share price as a function of time. So here, you see I've got a comment here, and date, comma, blah, blah, blah. Now let's run tabify my CSV, and then we'll tabify Google share price, and we'll output it as a TSV file. Let's take a look. Again, I haven't changed my original file, and here I've made a tab separated version. Yeah. Sorry, I missed?
The head comment?
Yes.
It's breaking on Windows boxes.
The head comment is breaking on Windows boxes. In what sense?
It's not recognized as an nor is currently an operable program bash file. It's taking on error.
So is it trying to, when you're doing that, you're having a problem when it's writing that file?
Just trying to run that.
Oh, when you're doing a cat on that. Does anyone know in Windows another way to show, maybe, will more work for you? Or head? Or instead of cat, can you just try head? Oh, type? More works on Windows? I wonder if it isn't because there is that special hashtag there. You could edit that file and see what happens if you put something else in. I wonder if Windows is saying, oh, because you have a hashtag, I'm now expecting this to be an executable or something.
No, it's just that when you're escaping, then you're issuing an OS command. There is no head command on the Windows.
Oh, there's no head command on the window. So if you just if you got rid of this pipe thing where you have head, does that work? You just get rid of that?
It doesn't have more, it doesn't have cat, it just doesn't have.
It,
It doesn't have bash shell at all.
it doesn't have bash shell at all. Okay. Any other Windows people want to tell us how we can actually visualize the data on Windows? What's that?
If you want bash on Windows, you can install Git, and it comes with a bash shell.
Fernando says type. So if you do type there, what if we did, without going into a bash, what if we just did cat? No, that doesn't work. Yeah, that works. Can you just do cat without the exclamation point? All right, we're gonna solve this offline, counselors. Yes.
So when you're creating an output or you're opening a file for writing and it exists, do you need to, is there like the W exclamation point? You have to say to go ahead and overwrite.
The IPython magic by default will overwrite it. That's when I'm doing this this right here, or I think it's write file is there may be some commands, I don't know how to get access to that, where you can say don't overwrite it if it exists, but the default is when I do this, it actually overwrites my existing file.
I'm specifically asking about the open command.
Oh, yeah. So this open here, that's Python. We can try to figure out. So what's the question there?
If it already exists.
Yeah.
And you just say W, will it error out or will
No, it'll basically zero that one out, and it'll start over from scratch and say, no, we've got an empty file now with the same name as you had before. You could say, if OS path exists, out file name. And by the way, you notice Python knows the different variables that are in your namespace. So we've already put that in our namespace. So print already exists, return, and actually probably a nicer way to say that is if clobber end, and then we can create a new keyword called clobber, which is false. So it'll refuse now to actually overwrite it. So if it's not clobber, right? I'm going to refuse to run that thing. So let's see if that works. Already exists. Okay. Yeah. Yeah, we'll do that now. You can get even more primitive, like at the C level of how many characters you want to read in, and you can seek into open files and stuff like that.
I work with very large files, so I don't want
You don't want to read the whole thing. Yeah. Good. We'll get to that. Any other questions? Yep. Well, okay, so the question is about using pandas or other modules. For interacting with CSV files, you'd want to use pandas, except if it's super ugly, even pandas will die and crash, and you may have to actually clean up a file before you even give it to something else that knows how to use it. I'm using CSV files here as an exemplar just because I wanted to also show you like using replace on strings. So a nice thing is going between CSV files and tab separated files. But there are many times when you'd want to open up data that isn't tabular in format, right? It could be all of Shakespeare's corpus and you want to replace every word cur for dog or something. So I don't know, I just made that up. So there's many reasons why you wouldn't want to use one of the sort of off-the-shelf things that can do somewhat of what we just built from scratch. All right, so file I/O, read and write. So there's even some more interesting things we can do with files. SHUtil is a module that's actually preferred for copying and archiving. So instead of actually saying, I need to copy this file, one way is you could call out and make a system call and say, use the Unix version of copy, or you can use the built-in modules within Python, and that's the SHUtil. And oftentimes when you're running large-scale code, you want to save temporary files, but you want to make sure that those temporary files don't interact with other temporary files that are created by other instances of your programs. So if your temporary files are called \temp/foo.dat, and you always call them that way, at some point you're going to be running code, and you'll be running code that you built a year ago, and they'll both be trying to write into this foo.dat, and that's going to be a big problem. Instead, you'll wind up using this thing called temporary file or temp file. It's again a built-in. So import temp file, temp equals temp file.temporary file. We get back a file I/O buffer, and if I want, I can actually name that file. So I can say it's going to have a suffix of .csv, a prefix of boot, and I want to stick it in the directory /temp. And when I close it, I don't want you to delete it. The default is to actually delete temporary files, so it cleans it up for you, because it really is, Python really is assuming that you're going to make it temporary. So here I got exactly what I wanted. I got some random string in here. And it's in the right directory. It's got the right prefix and the right suffix. If I run it again, get a different thing. Again. I'm just looting my temp. Okay? So that's very nice. It creates an actual file on disk that you can interact with. So now I can write a whole bunch of strings in here. It looks a little bit like a CSV file. I'm going to use UTF encoding for those of you that know what that is and care. And I'm going to do a byte encoding. And I'm saving what the name is. So I'm basically saving it into temp. And you see that it's now on disk, and it hasn't been deleted. If I set delete equals true, and then I write into that, it's saying that file that I just created that I wrote into, I closed it, so it's not there anymore. If I put this close after, and I run this again, so there's the name. Now I'm going to write into that. I'm going to look at that file, and then I'm going to close the file. That actually wound up not working. It didn't give me an error. Why do you think that didn't work? This is a little bit at the primitive level for those who have worked with file I/O stuff before. Anyone take a guess? Why didn't it print out what was in that file? It's not the shell. It's because we didn't flush the writing of that we didn't force basically this write to actually get what's called flushed into that buffer. So the file existed, it was open, we wrote into it, but the operating system said, well, I'm not sure if you're really done yet, so I'm just going to hold off. You can actually force the flushing of a buffer into a file. And that's actually kind of nice. If you've got long-running programs and you print out some statement saying I'm here, oftentimes that print statement won't show up for a while because the operating system's saying, I'm not sure if you really are done with all of your instructions on the printing. And since you haven't started printing something else, I'm not sure what's going on yet. You can actually force the flushing of a buffer where you're saying print to standard out or actually flush this data directly to that file. We'll see later how to do that, but just wanted you to see that for the first time. All right, so now we'll have a temporary named file, same stuff that we had before. We're going to get the name of that file. We're going to write stuff in. And here we're back to where we were before. That's the name of the file. Here's what's inside of that file. Any questions? Okay. I should say one of the initial places where you're going to wind up using or thinking that you should be using a lot of the file I/O is when you're writing out log files. So if you're actually running through, again, a long script or you've got some web server that you've built that's up and running and you want to know every time that somebody's connected and save that to disk, a very tempting thing would be to build your own logging system. But Python has something called logging. It's a logging module, and it deals with all of that stuff for you, and it's thread safe, et cetera, so multiple threads can be writing into the same file, et cetera. So it's good practice to start using this file I/O stuff, but what happens is there are many times when you would want to be using it when somebody else has probably already built a module to do that use case. So just be aware of that. Okay, now we're going to do something that's like files, except they're not files. They look like files to Python, but they're not actually writing anything onto an actual disk, and you're not doing any sort of I/O between the Python interpreter and its executable and the disk and the OS. Here we have a new module introducing now called .io, and io.stringio allows you to write strings into something that looks like a file. And using get value, you can see what was in that file. And because this is like a file, we can seek around just like it was on a normal open file that was on disk. And we can do a read lines just like it was a normal file. And we can go to the first place, which is actually the second, after the hashtag there, and we can read what's there. I can close it just like it was a file, and now I can write to it. Oh wait, I can't write to it because I'm trying to do an I/O operation on a closed file. I can have it be considered a byte file. That is, rather than storing things as text, it's going to store them in byte format. I can seek. I can write stuff into that, and then I can print it out. So you notice when I wrote into here, I wrote this, and I basically replaced this right here. But if I made lots of stuff in here, I'm going to wind up overwriting. Where am I seeking to here? Seeking back to 0. Yeah, so I overwrote all the stuff that was in there. So this is not the same as like writing into a string and concatenating strings together. You're literally going into the memory of what the operating system considers a file or what looks like a file, and you're going to the second place and you're just writing as many characters as you want. So what's nice about string I/O is that it allows you to, without having to interact with the operating system and to create temporary files, to basically create the notion of a temporary file in the form of a variable that you can play with and interact with as if it was an open file. What's nice about this as well is that when you're doing tests, you can build up little variables that wind up behaving like they were open files. And you can write tests against something that you know and guarantee is there because it's in the code. It's not living in your operating system. Okay, and last we're going to look at the SubProcess module. From SubProcess, import star. Again, that's bad coding practice. It just makes it easier when we type stuff out in the interactive session here. This is the preferred way to interact with other programs. This is essentially what you would be doing on the command line. So you use this thing called popen, which is part of the SubProcess module. And here we're just going to ls, or on Windows, perhaps dir winds up working. We're going to open up a shell as part of that, which allows us to get all the environment variables. And we're going to send the standard out from that shell to this thing called pipe. And we're going to grab the process ID, the PID of that. So this number will be different for you. This is basically what your operating system assigns. And we're going to do an ls. This is what you saw as a Python thing from before, IPython thing that allows us to take the output of a bash result and store it in a Python string. And we're now going to do a printout of the read lines, because this is now considered, this process.std out is considered an open file, and we're just going to read it. And you should notice, these are basically the same thing. If I do popen van Rossum trump 2016, shell true standard out is pipe, standard error is pipe, that means I'm effectively grabbing the standard out and the standard error. And I read those lines from the standard error, you see that there's no way that Guido would work with Trump. That file doesn't exist. And so what's very cool about this, and obviously won't have time to go into all the details, is that you could in principle have an interactive program running over here, and you could have Python, and Python can be talking back and forth. So it can start the program, and then it can wait for the input that's, maybe this program is some chatbot, and it says, tell me your name, and then Python says, my name is Guido. And then it says, hi Guido, what's your age? And it could be looking, the Python program could be looking at the standard out and saying, okay, I've just found something that I know what to do with, and it can actually respond back to that through standard in. So standard in, standard out, standard error are the typical ways within the Unix environment that you wind up interacting with a program on the command line. And Python now has the ability to get the low-level access that you would be able to get access to as a person. Yes?
So the open doesn't wait for the process to finish, or can it be made not to wait?
Yes, there are lots of things. You'll have to look in the SubProcess module to say there's a p.wait, I believe, and that will wait for the process to finish before it keeps on going on. So you can allow your Python program to essentially block while something else is happening, and that could take days. It could take seconds, it could take milliseconds, but if it's a requirement that that process finishes before you go on, you can do that. In this case, I didn't wait. I just let the ls happen. And that is interesting because I would actually get to see the file buffer filling up. If I was doing some really big ls across my whole laptop, it would just be filling up this file buffer, which is the standard out, from the process that I wound up opening. Okay? Any questions about that? Don't.
I got an error on the LS. It says LS is not recognizable as an internal or external command.
Are you on Windows?
Yeah.
It may be that you can't use ls. I think you would use dir. So it's not found on Mac. Does dir work?
I didn't want to cut it out. It works.
Okay. So Windows, so I'll say that for posterity, Windows, use dir. Okay. It's often advisable to your question to wait. So here's an example where I'd want to basically look for all the .py files in my entire laptop. So I go boop. This will block until the search is done, and you see in IPython, you get a little asterisk here when stuff is working, when the kernel is doing work, or you see this filled in circle. So that may take a long time. Any questions before we have our little musical interlude? So the difference between a temporary file and a normal file is that the Python has this temporary file module that creates a file for you with essentially a random name so that it can be saved on disk if you really want to. A normal file is typically one that you already know about, or you created, or you found when you did an ls as part of your Python flow. But from the operating system's perspective and Python's perspective, a temporary file and a file that was normal, they're identical to each other once they've been created. But Python gives you all this nice extra stuff to do all the cleanup. So if you just break out of your Python interpreter and you had 55,000 temporary files open, they would all gracefully close down for you and get deleted.